Welcome to lesson 4.4. We're going to be looking at trigonometric functions of any angle. So objectives, we're going to use the definition of trigonometric functions of any angle, use the signs of the trigonometric functions, find reference angles, and then use reference angles to evaluate trigonometric functions. So this is really the same thing that we've been looking at. It's just we're going to define it instead of A, B, and C, X, Y, and R, where X is the, like for any given point on the unit circle, X is going to be how far to the right or right or left it is. Y is going to be it's how far up or down it is. But if you make a right triangle out of the coordinate plane essentially in the point, and then R is going to be the hypotenuse, right? And we're calling it R because it's going to be the radius of the circle. So sine is y over r, which is opposite over hypotenuse. Cosine is x over r, which is adjacent over hypotenuse. Tangent is y over x, which is opposite over adjacent. And then the other ones are just, again, reciprocals. So if we're tasked with evaluating a function, and we're just given a point 1, -3, find each of the 6 trigonometric functions of that angle. So what you know to start with is that if this ordered pair down here is 1, -3, then x is 1, y is -3. We can find the r by simply using, well, it's a derivation of Pythagorean theorem. So a squared plus b squared equals c squared. Well, if I'm solving for, essentially, it's the c, our r is the hypotenuse, then it's the square root of x squared plus y squared. X is 1, y is -3. So you have 1 plus 9 is then 10. You got square root of 10. So that's your r. So then sine is going to be y over r. Well, y is -3, r is root 10. Rationalizing it, you end up with -3 root 10 over 10. Cosine is x over r, so it's 1 over root 10. Rationalizing it makes it root 10 over 10. Tangent's y over x, so -3 over 1, which is -3. Cosecant is r over y, so negative root 10 over 3. And it's negative because the 3 was negative, right? Secant is r over x, so it's root 10 over 1, which is just root 10. And cotangent is x over y, which is -1/3. So then these are just all the answers all together. All right, signs of trigonometric functions. Quadrant 1 is where they're all positive. Quadrant 2 is where sine and cosecant are positive. So that's because that's where your y's are positive, right? And x is negative. So that's why everything else is negative. Quadrant 4 is where cosine and secant are positive because that's where x's are positive and y's are negative. Quadrant 3, the only thing positive is tangent and cotangent. That's because your x's and y's are both negative. So the cosine and the sine and the secant and the cosecant, they're all negative. But tangent and cotangent are positive because they're a negative divided by a negative. That chart's going to be useful for what we're going to do here. So it says if sine of theta is less than 0. So sine is negative and cosine is negative. Name the quadrant in which the angle lies. Well, if they're both negative, that's got to be down here in quadrant 3. because sine is, again, your y, cosine is your x. They're both negative in quadrant 3. Now we're going to evaluate a trig function. So given that tangent is negative 1/3 and cosine is negative, find sine and secant. Because both tangent and cosine are negative, it has to be in quadrant 2. So if we know that, then we can say, all right, well, tangent is y over x. So it's 1 over negative 3. X is negative 3, y is 1. How do we know that the x is the one that's negative? It's because the cosine is given as a negative. You can then find your r value, which is root 10. You know that sine is y over r. You figured out that y is 1, and you figured out that r is root 10. So it's 1 over root 10. You got to rationalize it. It makes it root 10 over 10. Secant is r over x. So it's root 10 over negative 3. So negative root 10 over, I'm sorry, root 10 over negative 3. So then it's negative root 10 over 3. I'm going to leave this one as the exit ticket. So tangent is equal to negative 2/3, and cosine is positive. So then find the values of the remaining trigonometric functions. So we'll work that out as an exit ticket. Definition of a reference angle. So let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle. So acute means between 0 and 90, right? So it'd be something in the first quadrant, formed by the terminal side of theta and the x-axis. So if something is in the second quadrant, you're going to do 180 minus that angle, and that's going to get you the reference angle in the first quadrant that matches up with this one. The only thing that would be different about it is that the signs would be different, but all the other parts of the angle would be the same. If it ends up in the third quadrant, you do the angle minus 180 to get back to the angle that would be the matching one in quadrant 1. And then this one, if you're in the fourth quadrant, you do 360 minus the angle. So it all just depends on what quadrant you're in to get back to the first quadrant. So find the reference angle for each angle. If the angle is 210, then you are in you're in the third quadrant because you're between 180 and 270. So you do 210 minus 180 and you get 30. So that means the 30-degree angle matches up with the 210-degree angle. This works again if you are using radians instead of degrees. Radians would just be 2 pi is equal to 360. So if it's 7 pi over 4, you're going to subtract that because now you're in the fourth quadrant. If you're 7 pi over 4, you do 2 pi minus that angle, and you end up with pi over 4. It also works if you are doing a negative angle. If it's a negative angle, what you would do is add 2 pi or 360 to it to start. And so, for instance, here you would get 360 plus that would be 120, and then that doesn't make sense. Anyway, you'd end up with 60 degrees for that. Part D, if you had 3.6, you're just going to subtract pi from it because we're treating 3.6 like it's a radian. If it doesn't have degrees, it's not degrees, and you end up with 0.46. All right, so step 1, find a positive angle. less than 360 or 2 pi. That is coterminal with the given angle. Draw the angle in standard position, and then use the drawing to find the reference angle to find the given angle, the positive acute angle formed by the terminal side of the angle, and the x-axis is the reference angle. So here you would start with 665. And the first thing you're going to do is try to get it. You need the coterminal angle first. So you're going to subtract 360 from it. And you get 305. Then that's what you subtract from 360 to get the reference angle. And you end up with 55. Same thing with 15 pi over 4. The first thing you would do is subtract 2 pi from it, so 8 pi over 4. And you end up with that 7 pi over 4. Then that you subtract from 2 pi. And looks like you end up with 8 pi over 4. No, I'm sorry, that is 8 pi over 4 is 2 pi, and then you end up with pi over 4. So that's your answer there. It was negative 11 pi over 3. First thing you're going to do is add. Well, I guess you add 6 pi over 3, because you're going to add 2 pi to it. You end up with negative 5 pi over 3. And then you add another 6 pi over 3, and you end up with pi over 3. If you just do it all in one step, that's fine. But pi over 3 is the coterminal angle for negative 11 pi over 3. So you don't have to do an extra step on that. Right, the values of the trigonometric functions of a given angle theta are the same as the values of the trigonometric functions of the reference angle theta hat, except possibly for the sine. A function value of the acute reference angle theta hat is always positive. However, the same function value for theta may be positive or negative. So basically what it's saying is if you have an angle that's in one of the other quadrants, the functions are going to match up with the reference angle. It just might be positive or negative, as opposed to in the reference angle will always be positive. So the value of a trigonometric function of any angle theta is found as follows. Find the associated reference angle theta hat and the function value for theta hat. Use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. All right, that's a more complicated way to just say use the reference angles to find the exact value for sine of 300. So step 1 is to find the reference angle for 300. Well, 300 degrees is in the fourth quadrant. So you're going to do 360 minus that, and you're going to get 60. So the first step is just figuring out what is the reference angle. The reference angle for 300 is 60. And then use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. So sine of 300 is equal to negative sine of 60 because sine of 60 is positive, sine of 300, since we know that sine is negative in the fourth quadrant, we need to put that negative sign in front. That's what the prefixing that means. So if it is root 3 over 2, then sine of 300 is negative root 3 over 2. All right. Same exact thing. For 5 pi over 4, you're in the third quadrant. So what we're going to do is we're going to do 180 minus that, or I'm sorry, the angle minus 180, or in this case, since it's a radian, we're going to do the angle minus pi. And 5 pi over 4 minus pi is 4 pi over 4. You end up with pi over 4. So the reference angle is pi over 4. Use the quadrant in which that lies to prefix the appropriate sign of the function. Well, this is quadrant 3. And we know that tangent is positive in quadrant 3. So we're not prefixing a negative sign, right? We're essentially doing nothing. So you end up with the fact that 5 pi over 4 is the same thing as pi over 4, and it's 1. All right. So that's it. Let me know if you have any questions. Try the exit ticket, and we will go over this together tomorrow.